Last couple of lessons we've been focusing on sequences. We've dealt a little bit with coming up with the recursive formula for a sequence, but as far as having a defined formula, we haven't talked about that, and we haven't really talked about how to find an explicit formula for a sequence either. So that's what our focus on is going to be today, is coming up with formulas, explicit formulas and recursive formulas for a sequence. Now, anytime we have a sequence that has a constant difference, it means we're constantly increasing or constantly decreasing by the same amount, we would say it's an arithmetic sequence. And because we're constantly increasing by the same amount, we can look at these as being linear functions. So they're going to be straight lines. So first off, to see if it's a linear function, you always want to look to see if you're constantly increasing or decreasing by the same amount. So before we find the explicit formula for this, let's actually look at what the explicit formula is. Now the book, the way it describes explicit formula, I don't care for. We're going to use the same letters and everything, but as far as how it's going to be set up, I'm going to change it up a little bit. I think the way that I do it over here is a lot easier. Now let's talk about what each of these things mean. A sub n is always going to be there. That's always going to be part of your formula. That's like your y, and n is like your x. Like when we were graphing yesterday, remember when we graphed yesterday, we used n to represent our x. A sub n represents the value for the term, so that was your y. Same thing here. D is referring to our constant difference. Now, obviously, if we're adding the same amount each time, our d would be positive. Just remember, though, if we're subtracting the same amount each time, it's going to be a negative value for d. And a sub 1, you could probably guess, is going to be the first term of the sequence. So we have a new formula now to find the equation of a line, but remember, these are going to be an equation for an explicit formula for a sequence. And when we set it up like this, you do want to simplify it. So let's look at an example here. It says write an explicit formula for this sequence, for this arithmetic sequence, 4, 7, 10, and 13. And you can see that it is an arithmetic sequence because we're adding 3 each time. So we want to come up with a formula. So if I want to find any term, like if I want to do part B, to find the 30th term of the sequence, we want to be able to have a formula that will do that for us. So our first step is to use this formula. Now a little note about how our brain works and how to memorize formulas. You're going to have this formula memorized for the test. So an easy way to do that is every time we go to use the formula, write it down. Because if you just depend on trying to memorize it later on, your brain isn't going to be able to make the connection. Every time you write it down, your brain is reviewing it, and you're making it a connection to that specific problem. So then later on when we're talking about, on the test, finding an explicit formula for a sequence, your brain will already be able to recall that information faster. So that's a little information as far as how to memorize a formula. But now let's use it. So we're going to, our constant difference here, remember we're adding 3 each time, so it's a positive 3 times n minus 1, and our first term is 4. So now we're going to simplify this. I'm going to distribute the 3 through. So now I have 3n minus 3 plus 4. My last step, we're just going to simplify the negative 3 plus 4. So my explicit formula would be this. It would be 3n plus 1. So if I want to find the 30th term, I'm going to put 30 in there for n. So 3 times 30 is 90, plus 1 is 91. So there's your answer. Now using this method, the d, the constant difference, can be found by treating the sequence as a set of ordered pairs and finding the slopes. There are going to be times where sometimes we'll have to do that. And again, make sure you note the constant difference is the same as the rate of change. So if you notice here, we were adding 3 each time, and our slope is the same as what we were adding, our constant difference. Okay, why don't you guys give this one a shot. Try to find the explicit formula for this sequence. And so pause the video and hit play when you're ready to start. So you should have noticed that we're adding 4 each time here. So that's your constant difference. So when I go to set up my formula, again, that formula is a sub n equals d times n minus 1 plus our first term, a sub 1. So we're going to plug these numbers in. Our constant difference is 4. Our first term was 6. Distribute the 4 through. Simplify. And we get our explicit formula is going to be 4n plus 2. So hopefully you got that as your answer. So now to figure out what the 25th term of the sequence would be, we would take a sub n equals 4 times 25 plus 2. Well, 4 times 25 is 100. So the 25th term of the sequence would be 102. Okay, so that's an explicit formula. Okay, pretty easy. Okay, just once you know what the formula is, just a matter of plugging in your numbers and getting your answer. We've already talked about writing equations for writing this recursive formula for a sequence. But here's as far as a specific formula to follow. This is what we're going to use. Remember, we use a top row to represent the first term. We use a bottom row to represent how to find the next term in the sequence. So we would always, remember, a sub n minus 1 always refers to the previous term. And d is going to be your constant difference. And remember, that constant difference is the same as your rate of change. So let's look at the story problem. It says a cell phone company charges 25 cents per minute for overseas calls along with a 30 cents service charge. Write a recursive formula for the arithmetic sequence that represents the cost of a call lasting n minutes. So remember, rate of change is not only the same as the slope, but it's also the same as your constant difference when we're looking at setting up these formulas. So the rate of change here is we're being charged 25 cents per minute. Now we want to write that, we don't write things in terms of pennies, we write things in terms of dollars. So we can set this up as 0.25. Now to write a recursive formula, our top row is whatever the first term is. Well, they don't tell us the first term. We're going to have to figure out what the first term represents, or what it's going to be. And our first term is going to represent how much it would cost for a phone call lasting 1 minute. Well, a 1 minute phone call would be this 25 cents, but we also have this 30 cent service charge. That just means that doesn't matter how long the phone call is going to be, we're automatically going to be charged an extra 30 cents. So a 1 minute phone call would cost us 55 cents, because 25 cents plus 30 cents would bring you to 55 cents. Okay, so that's how we came up with that. You don't have to write this part down in your formula. I'm just showing you, so in case later you want to look to try to figure out how you got that as your answer, that's how you do it. Okay, so now we want to find the next term in the sequence, or how we would find the next term in the sequence. And that's going to be to take the previous term, and we're adding 25 cents each time. That's your constant difference, your rate of change. And we'd use this formula for the second term on. So we would say for integers where n is greater than or equal to 2. Now it says to graph the sequence. Remember, we don't connect these with a line. But one thing we can do is let's come up with the first 5 terms or so. Okay, so the first term would be 55 cents. Every term after that, we're going to add 25 cents. So the next term would be 80 cents. And then we would have $1.05. And then we would have $1.30. And then we would have $1.55. So my scale on my x-axis, I'm going to count by ones. On my y-axis, I have to go from $0 to $1.55. So if we count by 25 cents, this would work. So when x is 1, y is going to be 55 cents. When x is 2, or my second term, that's going to be 80 cents. Well, 75 would be here, so 80 cents would be right about there. My third term, or a 3-minute call, would cost me $1.05. The fourth term would cost me $1.30, so it's going to be a little over $1.25. And my fifth term would be $1.55. Again, this is a sequence, so we don't connect them with the line. Why don't you guys take and work this one out, and so hit pause and be ready to hit play when you're ready to check your answer. Okay, so for this one, electronic bulletin board charges $2 for each word of a classified ad plus $14 service charge. So your rate of change is this. This is going to be your D. So let's look at how we would set this up. So a recursive formula. We first have to figure out what our first term is going to be. Our first term is going to be, well, one word is going to cost us $2 plus a $14 service fee. So a one-word ad, which obviously you wouldn't do, is going to be $16. To find the next term, or the cost of more words for this particular posting, you'd take the previous term, and we're adding 2 each time. So to graph this, like we said, our first term is going to be 16. Our next term would be $2 more than that. It would be $18. And then $2 more than that would be $20, $22, and $24. So when I go to graph this, our first term is going to be 16. Well, let's first figure out what our scale is going to be. So we have to go from 0 to 24. So let's just count by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's count by 5s here. If we counted by 2s, I suppose we could have counted by 3s, that would have worked. But let's just count by 5s. So graphing the point 1 and 16 would be right here, 2 and 18, 3 and 20. I guess 18 would be down a little lower. 4 and 22, and 5 and 24. So your graph would look something like this. And again, we could graph more points here if we wanted to. They didn't specifically say how many to do, but usually at least 5 is a good number to start with unless they tell you otherwise. Now we're going to end there. We're not going to do these last examples because I want to, these aren't a major focus of your lesson. So we're going to skip these. So good luck on your assignment. And please make sure to come to see me if you have any further questions.